Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at solving problems involving the angle, sum, and difference formula for sine, cos, and tan. So I went through what those formula are in a previous video. Let's get straight to our first problem. We're going to calculate the exact value of cos of alpha plus beta. If sine alpha is this, cos beta is this, and we're told sine beta and cos alpha are less than 0. So we're going to start by using the angle sum formula for cosine. So cos of alpha plus beta is cos of the first times cos of the second minus sine of the first times sine of the second. Remember to be careful when using the cosine formula. It sort of goes the opposite way that you'd expect, in that there's a plus in the brackets, there's a minus between the two terms. So now all I'm going to do is change cos of beta to 9 over 41 and change sine of alpha to 0.28, which is 7 over 25. So how can I calculate the values of cos alpha and sine beta? Well, I can use this equation here. This identity keeps coming up, the Pythagorean identity that sine squared theta plus cos squared theta equals 1. Now we can rearrange that equation to make sine theta or cos theta the subject. So that means if you have a value of sine theta or cos theta, you can find the other one by using this process here. So sine beta is just going to be positive or negative square root of 1 minus cos of beta all squared. So putting that in our calculator, we get sine beta is 40 over 41. So it could be positive or negative, but because we were told in the question sine beta is negative, we're going to use sine beta is negative 40 over 41. So now let's calculate cos alpha. Of course, in this formula, I can just swap the coses and the sines around. So I can use cos theta equals positive or negative square root of 1 minus sine squared theta. So putting 1 minus 0.28 squared in our calculator, then square rooting, we get 24 over 25, which is 0.96. Once again, we were told though cos alpha is negative, so we take the negative square root. Cos of alpha will be minus 0.96 or negative 24 on 25. So putting that on our calculator, we get positive 64 over 1025, and we're done. Let's now look at a harder question. So we're going to use the angle sum and difference formula to simplify this expression here. Problem is, on top I've got a cos 2 theta, but on the bottom it's just sine of theta and cos of theta. So what I want to do is I want to rewrite this so it's in terms of cos theta and or sine theta. So to do that, I can use the double angle formula, because cos of 2 theta is just cos of theta plus theta. So once again, using the cosine angle sum formula, it's cos of the first, cos of the second, minus sine of the first, sine of the second. So I can make that a little easier to work with and write it as cos squared theta minus sine squared theta. So that means I've changed the top, so it's looking a little more like the bottom. It's got cos thetas and sine thetas. So I can rewrite my original expression like this. All I've done is change cos of 2 theta to cos squared theta minus sine squared theta. So I can't cross out anything here, can't cancel anything yet, but what I can do is note that the top is actually the difference of two squares, perfect square minus a perfect square. So I can factorize using the difference of two squares. So remember, for difference of two squares, you set up two brackets, square root the first and put it in both brackets, and then square root the second. So the square root of sine squared theta is just sine theta. And then once you've done that, one bracket gets a plus, one bracket gets a minus. So now I'm at a point where I can cancel because I've got the same thing on top as on bottom and it's being multiplied on top. So I can simply cross out this on the top and the bottom, and I'm just left with cos theta minus sine theta. So then I'm done, and it wouldn't have been possible without the angle sum formula. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.